Assalamualaikum warahmatullahi wabarakatuh. So, this our team for road assignment MAT272 Introduction to Mechanic. So, this our team Muhammad Hafiq bin Hashim, Muhammad Hasif bin Ismail and Muhammad Lutfi Hazim bin Muhammad Hilmi. So, will be presented by topic composition and resolution on force. So let's see on the slide.
Okay, now we look at resolution of force. What is actually resolution of force? Resolution of force is a refer to the process of breaking a single force into two or more components that acts in a specific direction, usually horizontal x-axis and vertical y-axis. All vector can be resolved into two components, which is x and y that I said earlier. That's x component refer to horizontal component, and the formula is fx equal to f cos theta. And for y component, which is refer to the vertical component, and the formula is fy equal to f sin theta. Actually, resolution of force is we want to resolve force into fy and fx. That's actually the mean of resolution of force.
So next is composition of forces. So what is composition of forces? Composition of forces is a process of determining a single resultant force that has the same effect as two or more forces acting simultaneously at the same point. Also known as compounding forces, there are three things that we can get from composition of forces, which is the first one, resultant force, second one, magnitude of resultant, and then the third one is direction of resultant forces. We can get the coordinate, the vector, by finding the component of x and component of y. For magnitude of resultant force, we can find it by using the formula, which is square root component summation of component x square plus with summation of component y square. And the last one is direction of resultant, which is we can use theta equal to arctangent summation of x over summation of component y.
Now we look at another question that related on our topic. Ali and Sarah are pulling a box where their friend Hannah is sitting on the box. Both Ali and Sarah pull with a force of 60 Newton each, making an angle 25 degree with the direction of motion. The total mass of Hannah and box is 35 kg, where the box is 1 kg. The frictional force between the box and the floor is 45 Newton. So, the question 1 asks to find the total of force and find the acceleration of box. So, let's redo. To find total of force, we need to find Fx and Fy first. To find Fx and Fy, we need to use the formula, which is Fx equal to F sin theta and Fy F sin theta. This is a same formula actually. For F1, we refer to the Ali, F2 we refer to the Sarah, F3 we refer to the fractional of the box. Okay, for F1, we get 60 cos 25 degree and 60 sin 25 degree. For F2, we get 60 cos 25 degree and negative sin 25 degree. Why negative here? Because F2 refer to into quadrant 4, which is Fx positive, Fy negative. That's why we get negative here. And for F3, we get negative 45. This is the same, but we refer to quadrant 2, which is Fx negative, Fy positive. So we already have the information. We just need to include the information into the formula, which is summation Fx and summation Fy. For summation Fx, we get 63.76 Newton, and summation Fy, we get 0 Newton. To find the acceleration of the box, we use the formula summation Fa equal to ma. Value for summation effects we already calculate before, we get 63.76, and the mass Hana and box is 25, so we just need to include the value that we have into the formula to find the acceleration, and we calculate that we get acceleration equal to 1.82 meters per second square.
So the question are related to our topic. So this question, a worker pull a refrigerator on a smooth floor using two rope. Rope 1 exert of force of 40 Newton at an angle of 60 degree, and rope 2 exert a force of 30 Newton at angle 30 degree from a positive axis. So the question is find the magnitude and direction of resultant force acting on the refrigerator. Okay, so to find the magnitude of resultant force, we need to find summation of Fx and summation of F1 first. And the formula to find Fx is F cos theta and Fy is F sin theta. So we can calculate F1 and F2, which is F1 I refer to root 1 and F2 is root 2. Okay, for F1, the value of Fx is 40 cos 60 and Fy is 40 sin 60 degree. For F2, the value of Fx is 30 cos 30 degree and Fy is 30 sin 30 degree. So we can calculate summation of Fx and Fy. So summation of Fx is 40 cos 60 theta 60 sorry 40 cos 60 degree plus 30 cos 30 degree, and for summation Fy 40 sin 60 degree plus 30 sin 30 degree. Okay, so we have a summation Fx and Fy where Fx is 45.98 Newton and Fy summation of Fy is 49.94 Newton. Now we can find the magnitude of resultant force by using formula set F summation Fx square plus summation Fy square. So the answer for magnitude of resultant force is 97.99 Newton. Sorry, 97.66 Newton. To find the direction of resultant force, we need to calculate by using direction formula is theta equal to tan inverse summation of Fx multiply by F summation of Fx over summation of Fy. So the answer is 47.2 degree.
Hi everyone, my name is Muhammad Azim and this is my question. So the first thing is let's take a look and read the question together. A boy is pulling a cart along a rough surface road by applying a force of 100 Newton through a rope that makes an angle of 25 degrees above the horizontal and moving in a constant velocity. So the question asks us to find two things, which is the first one us to resolve the pulling force into its horizontal and vertical components, and the other question asks us to find the friction against the cart. So let's solve the first question, which is the question asks us to resolve the pulling forces into horizontal and vertical components. So the question is actually a bit easy. We just need to resolve the pulling force, and we already learned how to resolve a process by using the information given, which is 25 degree above the horizontal and the force applied is 100 Newton. We can easily find the horizontal and vertical component, which is component of x equal to 100 cosine 25 degree, and the component of y equal to 100 sinus 35 degree. And let's move to our final question, which is to find the friction against the car. Since the question had mentioned about the movement of the car, which is in a constant velocity, so that means there is no acceleration applied to the car. So acceleration equal to 0. And by using the second Newton law, we can use the formula of F equal to ma, which is ma represent the mass and acceleration, and F will be used by component x, I mean summation component x. So summation component x equal to ma. Since acceleration equal to 0, therefore mass multiplied by acceleration will be equal to 0. So the formula change from summation component x equal to ma, we change it to summation component x equal to 0. And from that, we just need to look out for each component x that have in the question, which is the component x of pulling force and component x of friction force. Since friction force was moving to the leftward and also in the opposite of movement cards, we can assume that the friction force is in a negative state. Therefore, we write it as summation of component x equal to 100 cosine 35 degree plus negative friction, I mean negative lowercase f, and then 0 will be equal to 100 cosine 35 degree plus negative lowercase f, since summation of component s equal to 0. And then by using the calculator, the lowercase of f equal to 100 cos 35 degree, and our final answer is friction equal to 90.63 newtons. In conclusion, resolving and composition forces are fundamental techniques in vector mechanics. By resolving a force into its horizontal and vertical components, complex force system can be analyzed more easily. Conversely, compounding forces allows us to replace multiple forces acting at a point with a single resultant force that produces the same effect. This simplifies analysis in both static and dynamic systems. Mastery of these concepts is essential for solving real-world problems in physics and engineering.